Good morning, this is Jacob Smith. I'm presenting my final project. So the scope of the project was to see what sort of transient values would the cross-connecting segment of the piping experience, the piping that's shown. For example, would a hot slug that is twice the temperature of ambient produce a pressure increase at the cross-connect that would be, say, 300% greater than the design pressure for the system at that segment. It would be interesting to know because of what kind of fitting you can use to connect the two pipes. So would it be a special type of weld? Would it be a thread connection, some sort of socket, pipe nipple, etc. In the piping geometry, I have what I would consider to be common piping with a 1 in 3 nominal pipe size pipe, which I had to convert for meshing into metric. So the 3 MPS is 7.5 centimeters, 1 MPS is 3 centimeters. For my initial boundary condition, I wanted to create a manufacturing flow. So the 1 MPS has 573 Kelvin, 10 meter per second velocity, and 30.67 pascals, which comes to be just shy of 90 gallons per minute. The 3 MPS has the same temperature, but 1/10 of the pressure, which for that flow, it ends up having just a little bit less than 100 gallons per minute. For the solver, I ended up reusing the same from the OpenFOAM Modification 3 assignment, as well as the schemes. I ended up using a different solver and preconditioner for the solutions, as it helped slightly lower the trans number, which also leads to having a significantly smaller delta T as shown, as chasing that lower current number had me lowering the delta T, just trying to avoid all the floating point errors. I ended up using Gmesh to create my geometry and mesh. It took some getting used to, but I was finally able to import it into OpenFOAM. Initially, I wanted to do a 2D simulation to try to simplify the solution that I wanted, but it wasn't working out. So it gave me something more realistic this way. For the results, I had a few things that were going against me. One, it's a very big model. It's a diameter of 3 inches, that's half a foot long, has 3 pipes that's going through. It's also 3D, and overall my solution just seemed to take longer than they should to solve. But I was able to get a fraction of a second that I could analyze, and I was able to take a video of it. The results were not surprising. The velocity and the temperature had a uniform value until they reached the outlet. So as you can see in the graph, they didn't really change at all. But the video shows the pressure, which I thought was interesting. It just showed it being drastic, which is to be expected. Lastly, I wanted to share some lessons learned that I got. The model was simply too big. I should have scaled it, and I had the opportunity to do so. And I should have meshed the cross-connecting segment a lot finer, as opposed to having a relatively uniform meshing throughout the entire model. It added more than it really needed to. And I should have started this a lot sooner. In order for me to do a 30-second simulation, I estimated it would have taken me about 30 days or so to have enough time to let OpenFOAM run. That's it. Thank you.